Yeah, I did.
It looks cute.
It's semi-permanent. It's like a purplish color,
Uh-huh.
but it'll be gone in a couple weeks.
I say, yeah, you got to do that before you get back up to BYU, Idaho. They won't allow that.
Yeah.
So when do you move back up to BYU, Idaho, Charity, in the fall? Or I guess
Yeah,
what would it be?
I'm going back up in April.
Okay.
Yeah, for spring semester.
Okay, so the broadcast is started. Let me open up my quiz here. Huh. I had it open, but maybe not. Yeah, there it is. Okay. You guys ready to start?
Yeah.
Yes.
Okay, so question 1 through question 2.
Oh, yeah.
I guess I can start question 3. Find the margin of error for a 90% confidence interval when the standard deviation is, I don't remember that symbol's name already.
Sigma?
Sigma.
Yeah.
That's Sigma.
Yeah.
Okay.
Sigma, and the number is 25. And is it the z times sigma over the square root of the number? I think that's the formula, I think.
Yeah.
But it's asking us to find the margin of error. So I think it's the formula that has the m in it that we're trying to figure out.
Oh, is it? Yeah, I think the margin of error is the 1.96 times sigma over n squared, right?
Yes.
Or square root of n. Yeah.
And I think they're asking us to figure it out kind of backwards because we have n, which is 25.
Are you sure? Because I just
there was another way to write that.
The margin of error is m equals 2 times sigma over square root of n.
Yeah, divided.
Yeah. The other thing is confidence.
That's right. That's the other way to figure it out. You're right. There's too many formulas to this week.
Okay, so I'm going to do that really quick. So 2 times 50 divided by 5. So I have 20. Tell me what you guys get.
So let me put my calculator
Is that Kaylin's mic wigging out?
Is that mine? Are we good?
I think we're good now.
Okay, sorry. I don't know what that was about, but.
Did you hear it?
I did. I heard it.
Oh,
Okay, I got 20 as well.
All right. So everyone 20?
Yeah.
Okay. Question 4. Which of the following statements is true? Boy, I think it's going to be one of the middle ones. I think it's going to have something to do with a point estimator because I know mu and x bar are similar. Let me see if I wrote anything in my notes.
So I got 16.45.
We got 20. How did you get 16.45?
I got 16.45.
Because it says that we're using the margin of error of 90%.
Which is 1.645, except that we're just finding the formula that says the margin of error formula is z times sigma divided by square root of n.
Yep, that's the one.
Oh, so maybe I didn't do it right.
So are we supposed to do, or are we supposed to do 1.64?
Oh, I did it wrong. Hold on a second.
It should be 1.64.
Oh, okay. I was just using 2. Okay, let me redo that then. Then I did it wrong.
I did it wrong too.
Okay.
So then we need our 1.645 times
50
over square root of 25.
Yep.
I did this.
All right, let's try that again. 1.645 times 50. 5. Whoops. 5. So 16.45 is what you said, Monica?
Yes.
Yeah, that's
that's what I got too.
Okay.
16.45. All right.
And then
So
from the
question
video,
I have no idea what the answer is, but I think it's one of the two middle ones.
It's got to be one of the two middle ones.
I think,
estimate.
I think
I wrote
it's
down from the
the
video that the
second
point
one.
estimate is sample mean.
Say that again, Kayleen?
I wrote down from the video that the point estimate is the sample mean. So the
Oh.
point estimator would be the sample mean.
Then that would be the third one, C, right?
No, it will be the second one, or not?
I
Oh
think
man.
the second one.
Sample mean is X bar.
Oh, is it?
And the other one is population mean.
Yeah.
This is the point that the
I
sample
wrote down
mean.
Sample mean is the same thing as a point estimate. My notes. So,
Well, that would make sense though, because you have a sample mean, right, is just a portion of what would be the population mean. So I would think it's the second one down.
all right.
If you look in the book,
Uh-huh.
in the beginning, it's 3.1. Says we have learned about several statistics, and then there is
The chart.
a chart, yeah, that says sample statistic, and there's the symbol, and then
Oh.
population parameter.
Yes. So the sample statistic is the X bar, and the population parameter would be the U. So that's why I think it is number 2.
Yeah.
I think so.
Okay, next one. Gina wants to construct a 95% confidence interval. She knows the standard deviation is 113. She collects the sample size of 64 and X bar is 526. So what is the point estimate for the true GMAT score? The point estimate
That should be the sample mean.
526.
Yeah, it would be the 526.
Okay. 526 for that. How many questions are in this thing? Okay, let me do another one. Number 6 says, what's the margin of error for 95% confidence? And is that where we're just going to put the Z-score? Or
No. Well, that's
That
what we
would
gotta
be
get.
1.96.
Yeah,
Yeah.
1.96 times standard deviation, which I have to go back
is
up.
113 divided
Okay.
by the square root of the sample size, which is 64.
Okay, I'm going to do that in my calculator. 6 times
27.685.
27.685 is what I got to. Yep.
That's what I got as well.
27.685.
6881.
All right.
I got 27.685,
Yeah.
Yeah,
Monica.
me too.
Okay.
Monica, you want to do the next view?
Okay. What is the lower limit of this confidence interval? Okay. So we use the formula. So that would be, you just need to know the number specific. It's 526 minus 113.
It should be that 27.685 that we just got, right?
Oh,
Massive.
yeah. 27.6.
So it's plus or minus. I gotta
Then-
find my.
113 divided the square root of 64.
Wait, what?
Well, she's doing the whole equation, which is
Yeah.
fine, but we got that section, that part that you're talking about, the 113 divided by the square root of 64. We just calculated that in the previous problem, Monica. So all we have to do now is take that 526 and subtract it by the answer we got in the previous problem, and that should be our lower interval.
So it'd be 498.315.
Are you
Is
sure
everyone
we have to
following me?
subtract? I was confused with that in the videos because they are not subtracting; they are doing the formula.
You're right, and that you can do the formula. So go ahead and do the formula, because you should get the same answer by doing the formula or by just taking the answer that we got above that we calculated and subtracting it and adding it to the
Okay, so I'm doing it
For the
now, but you know.
Go ahead and do it. Because I have an answer of 498.315.
Okay, that's what I have as well.
Oh, I added it. Let me redo it. 526.
You'll add it.
That's the next question. You're just trying to go ahead.
The answer. All right, so 493.315, right?
It should be 498.
Oh, 498.315.
But I have
The mean was 526, right?
498.315 is what I had on my calculator.
So what did you got? I love this.
Calm down. You're okay.
No, my
So that we
computer shut down, so I can't see.
Oh, no. I hate that. So just you write down all the answers for us for sure. And then you could probably
It's
go back
happening.
to the quiz.
Where was the answer there? Number 7.
So
It's 498.315.
498.
0.315.
Mm-hmm. Oh, that's the lower. Yeah, I was thinking upper. Okay.
And then the upper one is the next question.
I got 553.685.
In here.
correct.
Okay, I got it.
Okay. There are 6 ones left. So I'll go ahead and grab one.
Yeah.
What would happen to the width of the confidence interval if Gina increased the sample size? So when the sample size increases, the confidence level should decrease.
Decrease.
I agree.
Okay, and I'll do number 10. What would happen to the width of the confidence level if Gina changed it to 99 confidence interval? It should increase.
Yep, agreed.
Because essentially that Z-bar score is going to go from that 1.96, we multiplied it, and become a bigger number, so it should increase along with everything else. Is everyone following that? I kind of had to talk myself through that. Like, what? And I'll read part of 11, and then I guess we'll go from there. Bright Bulb Light Bulb Company, say that 10 times fast, is planning a study to assess the average life expectancy of their light bulbs. They know that the standard deviation is 400 hours, and they want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
Okay.
All right, this is the one where,
That one.
yeah.
That one.
Okay, so do we use the N formula?
Yeah, so they want 95, so 1.96 times the standard deviation, which is our 400 hours, divided by the margin of error, which is 50, should give us the number that we need.
What's what formula are you doing? Is that the N minus
Yes,
Z times
yes.
the sigma over
Yeah,
M?
because you got it, because they gave us the margin of error that they want, which is 50.
Okay.
So I have 15.68, so we need to round it to 16.
Okay, good. I got that too.
Okay, so give me a second to get caught up. Sorry. I
No
just want
problem.
to
We'll walk you through it real fast. So again, we're looking for N, which is they're looking for the sample mean. You're going to want to take the Z-score, and in this case, because they want 95%, we want that 1.96. And then we're going to have to multiply that by the standard deviation, which is 400 hours, and then divide that by the margin of error, 50.
And then we have, is it N equals? Oh, it's N equals. I had the formula written down wrong. It's N equals that,
Yeah.
right?
Yeah.
Okay,
You got it. So that's,
let me just put it in here really quick.
I do have quick.
no, go ahead.
Don't we have to then, I don't know the word, multiply it by 2? No. Because the formula has a 2.
Square
Oh,
root.
you're right. You're right. Thank you so
Oh,
much.
square
Yes, yes. I tried to.
Yeah, I don't know the
Yeah,
word
now we have to-
in English for that.
So 245.862, is that what you guys got?
Wait, what?
Where?
245.862?
Yes.
245,
Yes.
245.886.
Oh, I haven't squared it. Are we squaring the rounded number or the?
No, you're supposed to square round at the very end.
Okay.
Yeah, so we got to take that 15 and then square it. Thank you. And here I have it underlined and highlighted and everything, and I keep forgetting to square it.
So then will be 246.
So way to go, Monica.
So
You got it.
Oh, you're right.
246 should be
You're
ours.
right. That has to go to the nearest whole number.
Yeah.
Okay.
Thanks,
Okay,
Monica.
so
Right.
so 246.
246.
Have to remember that on the next quiz.
Yeah.
I'll put a star next
Okay,
to it.
I'll do the next one.
All right.
Okay.
All right. The mean salary of actuaries is $100,000. The standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. We set up a hypothesis test with the level of significance 0.05 and the null is 100,000. The alternate does not equal 100,000. You collect a simple random sample of n equals 36 women's salaries and find that x bar equals 111,000.
Oh man, here we go.
That's a lot of numbers. Okay.
I'm like writing down all these numbers. Scroll down now.
What is the lower limit of this 90 confidence interval? Oh, hold up. Okay.
Of the confidence interval.
Okay, so where to even begin? So we want the lower limit.
That would be
Like, I guess we should start with
111,000.
So,
So it's x bar minus z times standard deviation over square root of n formula, right?
Yes.
Okay.
So 111,000, right? Yeah. 1,000 z squared. Oh, what's the z squared? Is it 1.96?
yes, 1.96 because
Yeah.
they wanted the 95%. 36.
Times 36 and 32 divided by the square root of.
So it's 99,001.5333.
Hold on. I just wrote it down. Let me actually do it now. Okay. You don't for the formula, you don't multiply it by the wait, so it's x bar times the z score.
X bar minus the z. X
Oh,
bar
minus. Oh, that's what I was. Okay. Okay, I got you.
I think I might have gotten what Monica got. Monica, what'd you say?
99,000, and then rounded it will be 99,002.
That's not what I got.
Minus 11.99.
I'm gonna do it again.
I have $99,002. If I
What?
were to just round that number.
Okay, maybe I wrote some number down. Oh, you know, I wrote one of the numbers down. I was off in writing it by 6, or I thought it was a 0. I thought it was a 6, but it was a 0. All right, let me do it again. 36730 times 6 equals divided by 6 equals 119.
Okay, what'd you guys get? 99,001.
99,000. Yeah. So we got to round it to this as to the nearest whole number. So it should be $99,002.
Okay, perfect.
Okay, give me just one more second, guys. Sorry.
No problem. No, we want you to get the same answer. We want you to feel confident in what we're doing.
99998 equals. So 99002. Yep, I got the same thing finally.
Okay. Oh, and so then for the next one, we just add it.
So the next one is 122,998.
Or are they going to be 999? Because if you take the 6 and round that to a 5, and then the 5 makes the 8 and 9. Dang
Okay,
it.
hold on. I'm gonna get there too. Okay, upper limit now.
I
So-
wasn't sure. Because it's a 4,
Plus.
so then we round to 8, or do we have to round to 9?
Did I
I think
do
we should
that
round.
right? I got 122,998.46.
Correct.
Okay,
But you have to
0.46.
round up always.
but then you
But
just
where-
shortened the 8, right?
Nope, it's got to round up always. They said always round up, even if it's a 0.4.
Oh,
Okay.
No, because that's when you need the people number. That's for the sample mean that you need, because you need a whole person. But for
Oh.
this case, because
This is the
let's go
confidence
8.
interval.
Yeah, this is the
Oh, so
confidence
it's 8?
interval.
You're right.
So we're
Why
trying
are
to do 8.
Doing this
Unless
to
we were to take into account that it's a 4-6 and we round the 6 to a 5, the 4 to a 5, but
No,
let's
no,
just leave it at
no.
8. Let's
I
leave it
think
at
it's at 8, yeah.
8. Let's not overcomplicate it. shall
They're
we?
totally tricking us.
So I'll
Okay.
do the
Go ahead,
last one.
Monica. You want to do the last one?
Yeah, I think I haven't done anything. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are, I have it here.
Oh, yeah.
A simple random sample was drawn from the population, that's 1. Then the X sigma, or no, that is normally distributed, the third one. So all of the above.
Mhm.
All of the above. Okay, I'm going to go submit the quiz real quick to see if we got them all right.
All right, we'll hold off for a second.
I was concerned with 7 and 8 because I got a different answer.
Okay, we got 100%.
Hooray.
Okay, so you want to go back to 7 and 8 though, yes, Monica?
Oh, but I'll check it because I was doing the formula, like the whole formula, and I got different numbers, so I want to know what's
Okay.
wrong.
What happened?
Yeah.
You're fine, but if you have problems, email us then.
Okay, thank you. Thank you.
Let me submit mine really quick. Make sure it looks good too.
Yeah.
Hooray!
Perfect.
All right. Thank you, ladies. And I guess any questions? We're all good?
Nope, I'm not
Yeah.
good.
Okay. We will see you guys in
Thursday.
what today? In
Yeah,
2 days.
Tuesday.
I never know if I'm on Tuesday or Thursday. See you guys in 2 days.
All right.
Okay, thank you.